Okay, so we'll start the next thing on the equation of lines with your formula that you're given. This is, of course, the gradient formula. It's on your formula sheet. Right above it is the standard form of a line, and next to it's the general form. But we're going to concentrate on this one right here. Y equals mx plus c, and it defines m down here. So this is the gradient. That's your variable, your independent variable. This is y, another variable, your dependent variable. C is a constant. That's why they use the letter C, to remind you that it's not a variable. In fact, when I learned it as mx plus b, so I might slip and say that from time to time. But this is the standard form of a line. This is the gradient. And if you look at it, then if you put 0 in for x, you're going to get y equals c. So what this tells you is that the point 0, c is on the graph, and that's the y-intercept. So this is also known as slope-intercept form. Y equals mx plus c. Let me erase these lines. And now we'll look at some problems. Let's look at problem from the text, 3E, number 1. They give you the gradient and they ask you about how to find the equation of the line, the y equals mx plus c equation, given some information about it. So the first one, let me move it so you can see what we're looking at here. All right. The first one says gradient 3 passes through the point 1, 4. Then we have gradient 5/3. Passes through the point 4, 8. Then we have gradient minus 2 passing through the point -3, 0. And put all your answers in the form y equals mx plus c. Now let me put it over here on the blank part, and that's where we'll do our working. Okay, so first one. The first one says gradient 3, so that's m equals 3. And then it also says it passes through the point 1, 4. Okay, so this is also called point slope form. They give you a point gradient form. They give you a point and the gradient, find the equation. Since we already know m, we're really halfway there. All we need to do is find c. Now there's a couple ways to do this, but I think the easiest way you'll find is just go back and put it in y equals mx plus c. We have everything here except c. I have an x and a y. All right, so I'll put them in. Y is 4, m is 3. And I'm going to multiply that by x, which is 1, and then I just don't know what c is. Well, 4 then equals 3 plus c, and easy enough to see, subtract 3 from both sides, 1 is equal to c. So you put all this together, and then the equation of this line will be y equals mx plus c. You should make sure this point is on the line. If I put 1 in here for x, I do get 4. But now the beauty of this is I can figure any x, I can figure out what y goes with it. So this is a line with gradient 3 that goes through that point. It's obviously gradient 3, and it obviously goes to that point. There's only one line that has that characteristic. Okay, that's for part A. Now, what happens in part B is very similar. They just changed the numbers around a little bit. In part B, they said the gradient is 5/3. All right, and it passes through the point 4, 8. 4, 8. Well, it's almost the same deal then. What we're going to do is we're going to say y equals mx plus c. So y equals mx plus c. The only difference here is it doesn't work out so nicely. These two numbers multiplied together don't give me a nice whole number. They give me a fraction. So what we're going to have here on this side is going to, well, you can also write this as 4 over 1 if it makes it easier for multiplying. That'll be 20 over 3 plus c. To make it easier, let's find a common denominator right now. If I've got, this is 8 over 1, and I want a common denominator with this for 3, I'm going to multiply top and bottom by 3. I get 24 over 3. So, not too bad here. I can now almost see the answer. If I subtract 20/3 from each side, I'm going to get 4/3 equals c. So now I know c. I was given m, so I can put them together. And I can say y equals mx plus c. Check and see if the answer is consistent with the point that we're given. If I put 4 in here, I have 4 times 5/3. Looks pretty awful. 4 times 5/3 will be 20/3. 20/3. Okay, I add 4/3 to it. I get 24/3. Oh, well, that is 8, not 6. It's 8, which is what it's supposed to be. So it does check. This is the equation of the line with this gradient through that point. It works the same for the third one. You have a negative number, but everything we're doing here is just using that formula over and over again with x and y given from the point and the gradient, the number that's given.